Not yet. Are you live? Not yet. Are you live? Not yet. Are you live? Not yet. Tuko live? Okay, sawa. Karibuni sana. Welcome. The last time we stopped at self in singleton methods and class method definition. And we saw that, let's start up that. Okay, let me use the white one. I can use that, then start up right. We defined a class. We can call it a class. This has a method called self dot say my name. Okay. When you tell it to say its name, it should say self and end. Then you have another class called your class. It's supposed to inherit, which inherits from my class. Okay. And so if you do your class dot say my name, the receiver in this case will be your class. So my name will be, okay, when you call say my name, it will tell you your class, if I'm not wrong. Yes, returns nothing because of the puts. Okay, then we move over to, that's for our singleton methods, classes. Okay, this I think was here. Then using self instead of the hard-coded class names. By the way, of a little programming tip, here's a variation of the last one. The last one, I think they're referring to this. Yes, no, yes, no, yes, yes. They're referring to this one. Where you create an object, then you say object dot. No, they're not talking about that. They're talking about this. Create a class. The class has the method X. So you say that def C has method X. A short form for that would be to say self.x. So that if you say c.x, if you have to call this, you'll do c.x. It will call this. Note that the use of self.x in one rather than c of x, this way of writing class method takes advantage of the fact that in class definition, the self is c. That way. So this is the same as c.x. Self.x version offers a slight advantage in that if you ever rename your class, you'll retain the self.x. If you had coded this, you'll have to change for every instance of c.x. Okay, but you don't have to be careful, but you do have to be careful. Remember that self inside a method is always the object in which the method was called. Okay, we can have D inherits from C, then D of X. D gets to call X because subclasses get to call class methods in their superclasses. Oh, I get it. The only reason D can call X is because this particular D, which is a subclass, has the ability to call the superclass methods, which is C. But the receiver is still D. Okay? As you'll see, if you run the code, the method this reports self correctly as being D, because it's D on which the method is called, sorry. Hadi hapo? Everything good. Being self at a given point in the program comes with some privileges. Yes, the chief privilege is that of serving as the default receiver of all the messages you'll see next. Okay. Unaendaga unakaria hivi, nikiangalia huku naona Jontes amekaa hapo, kiangalia huku Piento amekaria pale. Alafu ile dema anaitwa ile dema anakuwa huyu dem beshte yake na Jontes. Anakuwa na jina what? Ni imaginary friend. She's an imaginary friend. So hata yeye pia unamwona amekalia hapo, wanangoja kureceive messages. Sasa mimi ndio chief nimekaa. Wewe hujui umse ananielewa. Aelewi nini inafanyika. Ungekuwa unaelewa hii joke vizuri sana na hii explanation ingeingiana. Sorry. So it'd be the receiver, as we'll see next. Self as the default receiver of messages. When you call methods, that's when you send messages to objects. Usually use the dot. This dot that, this dot that, that. That's the normal full form of that in Ruby. But you have a special case for method calls in that if the receiver is self, you can omit the receiver and the dot. Ruby will use self as the default receiver, meaning the message will get sent to self as the following equivalences show. Instead of doing this, if you are in self, you can just say talk. Okay. If you're in ticket, you can just say venue. If you're in the string, you can just say capitalize. That is if you are inside the string. Yes. A class method. How exactly? Mm-hmm. No. Okay, let's try this. Yo, man. Class yo, man. So it has this self dot, my name. We have def. So is it based on this? So what are you asking? If you can call? If I can call my name inside this, so that why can't the terminal sometimes behave like text editor? So now I'm planning to remove this. Okay, sorted. So you're asking if I can do inside this, if I can do my name. This is inside the method. So you're asking if I can call this as long as this is self. I don't think it's called. This is a definition. How do you call a class? You can only call methods. So at what point will this be called? It only executes when it's told to. So how do you tell your men to execute? Are you getting what I'm saying? If you have 13 controllers, you can't say that all of them get executed at the same time. So how do you tell this to get executed so that this can run? What if we do .new? Nothing, it will just create an instance of this. Nothing is being called other than the new. This is the same as doing my underscore name. So that won't work. I think technically because we cannot call the class. We can only call methods. Nugget. All right. So you can give a method and a local variable the same name, but it's rarely if it's ever a good idea, as in we avoid to. If both the method and the variable of a given name exist, you use the bare identifier like this for the variable. Then for the method, use self dot or call it with an empty argument like this. Because variables don't take arguments, the parentheses will definitely distinguish it from. So what this means is you can have a variable called you can have this variable, you can have this method, both at the same time. So if you do, yo man, I need to do this, man. Then you call my, I have to do dot new, my edges, and nil. But I can also use my edges inside here. What happens? I do that. What happens? Will it know that we're referring to this? Because you can give a method and a local variable the same name, but it's rarely a good idea. If both these, the variable and the method have the same name, okay, when you just say talk, then that's a variable. But if you do self.talk, we're talking about the method. Or if you add the parentheses, we'll be talking about the method. So technically, if you do this, then that will now be a method call. Okay, let's try. stack level too deep, so it was not able to. It could not distinguish between the local variable and the method. But outside, this can work. Outside my edges. If I'm not wrong, let me just try this. It should be available. Let's try that here. Okay, let's do the printing edge thing. What if I call the method? Oh, all of this. Nil. That's my edges. What if we do my edges that? So it means it's not seeing this. Okay. Okay, let's try this then. All that. Will return that. This can be the same value as this. But if you just have the variable name without any assignment, it will try to call the method. And it's calling the method inside the method. That's why it's having the stack too deep problem. Sindio? Yeah. La 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 la. Let's see this concept in action by inducing a situation where we know what self is, then we test the dotless form of the method calling. In the top, we know it's always the main. Self is the class object, and we know how to add methods directly to classes, so we can have such a thing. C dot no dot, then this is no dot. We call this. As long as self is C, you can call this method with no dot. So this is C. This is C dot no dot. You can call this without any dot. The first call to no dot, this one, doesn't have to have an explicit receiver. So if I have my edges, right where you are talking about, right here. We're talking about this. Or we called my name, but nothing happened. But again, for us to call my name, Okay, let me remove this and this. It has to be a class method. If we try this, it calls it. But the weird thing is, we have another definition. Not call it. Or it does call it. Only that it does not print. Yes, it's called when you define. So how is it? Oh, so this means that every time we have the class, then my name will be called. So, because I'm trying to equate it to like Rails, if your Rails app has 13 controllers, okay, at what point are the classes being called? Or it's the root who chooses which controller to be called, okay? And the moment the controller is called, then this happens. It gets loaded into the system. Or what really happens for the Rails roots? It goes, decides which controller to be used, then an instance is created from that. So this might technically mean that my name will be run once when you deploy. For this particular case, when you deploy your app, your name, my name will be run, and at no other point. I don't know why I'm doing that assumption. Okay, this is what I mean. So we can call this file d.rb. We come here. And require d.rb. If we do this, then it will print that, and there's no other way that that will be called again. So that's why I'm theorizing that if you have such a thing in your controller, then it will only be called when you deploy. Or during Rails startup, when all the files are being required. When you're starting up Rails, you can require the files. That's the only point this will be called. Hiyo ndio theory yangu. Controller kama afikiria. When you recall. Get your other question? That's every time you create a request, a controller instance is created. Whatever I've drawn over there. For every request, there's a controller instance. But you can't call that without an instance. You must have an object. Every request must have a controller object. Every now and then. Then I remembered explaining that if you have a million requests in 1 hour, then that means a million objects, and your app will start hanging because you're full of RAM. Yeah, I remember saying that. Okay, so you can do that. We've just done that. The first call to this and determines the method call rather than this. It figures out you mean the shorthand for self. The message gets printed for this particular message, and the result, you see the output. The second time we call method to c.node, we are back outside the class definition. So c is no longer self. c.node, when we call this, we are inside the definition block, so self is C whenever we're here. But outside here, we're back outside the class definition, so C is no longer self. Therefore, to call this one, we need to specify the receiver, which is C. If you're inside this scope, you don't need. But once you're outside the class definition, you will have to. That's in short. The result of the second call, I don't know how to read this. Since it has a dot and another printing of the output of that method, the most common use of the dotless may occur when you're calling one instance method from another. For example, if you have this, okay, you have X and you have Y. If you want to call X inside Y, you can just say X, it will call this. Because once you create an instance of C, then the receiver will be that instance. So this X will call this since they are all instance methods. Okay. If you have a class, mine, with a method def, okay, then if you wants to call my, it will just do my and the definition call for method, then end that. If you have an instance, call it instance 1. That's the instance of mine. Okay. Now, this is now our instance. If we call your on that, the receiver is instance 1. Calling my will mean that the receiver at that point will be instance 1. Okay. Your, my. Okay. So the output will be this. Upon calling that, the method y, I think we've explained almost everything. There's one situation where you can't omit the object plus the dot notation. That's when the method call ends with an equal sign. So the problem is that if this is our situation, then her calls my name. Can remove that. Her calls my name. If this calls this, then we know that we're calling this particular method. What if you're calling the method name equal? If you call the method name equal, yeah, side pen. Setter methods, the equal sign in method names. Let's say we want to, this is like page 60. The price can be set along. So this is it. Set price, initialize. Then we went through all these and decided to name our method price equal. So this is what we decided to do. Have price, you can set the price by amount. Then you can ask for the price. We'll return the at price. So what we can do is we can give it an amount or we can ask it for the amount. So this means that we have a method called price equal, which we can call right here. We can call event.new.price. Oh, okay, let's just create an instance first called I1. Then I1.price, call the method price equal, give it 90. If you ask I1 for its price, it will give you 90. I1.her will be kwenda. I1 dot, I think it's my name. Did someone call me? Yeah. So the point is, if you want to call this price equal here, if you want to call this inside my name, let's say goods, we are setting your price. Then you can set the price. So if we decide to set the price as price, calling this method and saying that price equal 56. Since the default is this instance, we don't need self. Okay, let's start by doing this. We can start with this, your price, we can tell you your price and call this method. So remove that. Class my event, my name. Then if you call my name, it will call this particular method called price, which will give you your price. Okay. So to begin with, I can do equal event new p dot price. Okay. So let's call my name on it. P dot my name. Okay. It will put your price, then return price. So it will put your price and return the price, which is 900. So this method was called. What if you want to call price equal? So we can do setting your price, then we call price equal. We don't need self, but fine. So in this case, the problem will be it's never sure whether it's a variable or a method call. So you have to do self dot. Right? You just have to do this when calling methods with equal. Okay, let's go back to where we came from. Where were we? Okay. We were somewhere close to this. Okay, what's the time? 12 minutes. Okay, so if we have a setter method, self.venue equal rather than venue equal, if you want to call the method venue equal on self, the reason is that it always interprets the sequence this as an assignment to a local variable. To call this method on the current object, you need to include self explicitly. Otherwise, you'll end up with a variable called venue and you'll not call the setter method. The default to self as a receiver for dotless invocation allows you to streamline your code nicely in cases where one method makes use of another. The common use is composing a whole name from the component file. Okay, I don't know what it's trying to talk about, but you can have a whole name. Okay, the whole name will be n equal first name plus a space, then middle name. If middle name, then you can have the last name over there. Okay. We have attribute accessors. This attribute accessors allows you to get and set values. So if you set first name, then you set the middle name, then you set the last name, it will give you this. Get it take us through just this last part.
Hello, can you hear me? Of course. So, now it's you scrolling. Let me open my book. Oh, ni hapa peke yake. Iko kwangu. By the way. Happy kitu. Oh yeah, ina scroll. Okay, sorry people. Now, I hope this is so hard. So where were we? Hapo, si ndio? Okay, so the result, what? What? Chini. This one. The default to self. Okay. Okay. Awesome. So we have a class person, and inside it we have attribute setters. We have the first name, the middle name, and the last name. And then we have a method called whole name. Whole name defines n as the first name, which takes the first name plus an empty string. And then we have n. What does this sign mean? Append. Okay. So you append n with the middle name, and the middle name has been interpolated because it's been defined as a symbol, huko. And then if middle name, or yeah, as an attribute accessor. So if middle name, no, you do that if middle name. Sindio, you append to n the middle name if there's a middle name. If middle name true. So if there's a middle name, you append middle name to first name, and then you append the last name. So I have a feeling it will be the first name, then middle name, then last name. And then we have a new instance of person called David, and then David dot first name is being set to David, if I'm not wrong. You can try it out in your IRB. Unaweza jaribu. Haya. Oh yeah, let me share my screen. Trouty. Okay, so can you see my screen? Inzi nafanya nini? Um, my laptop is hanging. No, it's okay. It's back on. Let me get out of your screen. I'm on mine. Yeah. So and I was using your book. Let me open mine, Bessie. Desktop, Getty, G, Ruby, there. Well-grounded rubyist. Which section was it? Determining scope. Well, I hadn't reached that far. Yeah. Okay. So we have this. Let me copy this code single until hapo. Okay. First person attribute accessories. Naziandika zote. Okay. So we have a class, obviously, and then we have attribute accessors. I hope that's the spelling. We have maybe first name, and we have last name. Yeah. Then we want to define each and every one of them. So let's say n takes the first name, which will give it as an interpolated string, if I'm not wrong. It's a method. Oh, yeah. There's a method. So method full name. The full name, and then in here we have n, which is the first name. Okay. I'm assigning full names to first name and last name. First name is in the attribute accessor. It's like it's when what I understand from the attribute accessor, it has getter and setter methods together. It has an attribute writer for first name and it has an attribute setter for first name. If it has both, right now I am getting. Do we have a person? And that's full names. What else was he doing? Is that all for full name? Hmm. Okay. And then there's the now that we have a getter, we need to also have a setter of both. Okay, so what was the point here? Hapa nasema the default to self as receiver for dotless methods invocations allows you to streamline your code nicely in cases where one method makes use of another. A common case of composing a whole name from its components, first, optional, middle, and last. The following listing shows that the unique for doing this, using attributes for three name values and conditional logic to include the middle name plus a training space. Okay, so he had n and he did that. And then I have to set the first name and then set the last name and then call what? Did he call anything? Yeah, call middle name. But me, I'll have to call full name or the method. Mhm.
Basically, I think we're just trying to see how we can call, we can't, if we can't use certain
Mhm. Mm.
because after the way we bring our group, we
Mm.
have to set the first one.
Then set the middle name. Mm.
Then our method just gets the
Mm. Okay.
as in we are doing it like they're saying implicit set.
Okay.
Okay, I'll get that. When we are getting, we are unlimited. We are setting. But I think it's funny too. The reason self is optional is to make such a self is optional. Then silver is that which you love. So this is what makes it possible to have. Otherwise, it was not optional. Having then self must as and blah blah blah. Self the default to self and to silver allows you to simulate your code nicely in cases where the method uses other methods. So that you can use the method the method for last year, the method first year. You don't need to say the same. That's the whole point. So first name is a method, second name is a method.
Attribute accessors just upsets the hell out of me. So what do we do next? Undefined method attribute accessor. Hi, spell Vivo. Or it's, let me check. Accessor. That, oh, double R instead of double T. Attribute accessor. Yes, we have double C, double S. Or, yeah, double C, double S. Mhm. The phonics, that and that, and then end. So now we create a new instance of this class, I guess. Y dot kt. And then we we set we set y dot first name from what I can remember. Wait, and we set y dot last name. Did I do that right? So now we call the method on, yeah, there we have it. So so without the attribute accessors. So I don't have to change anything for the class. So if, what am I changing? Because we have class and then we have attribute accessors and we have the call or definition. Oh, def. Is it okay to do that? This looks wrong. It looks wrong. E equals 80. Dot t dot first name. Okay, so it just works the same. Inakaa weird. Si kusema self dot first name, self dot last name. Inakaa sijui. Inakaa too long. Me actually nilidhani attribute accessors ni variables for some reason. I'm knowing their methods today. So tumalizie, time elixir imefika. The method definition of whole name depends on the bare word method, holds to first name, middle name, and last name being sent to self. Self being the person instance, David in this example. The variable n serves as a string accumulator, because we keep on appending to it, with the components of the same added to it by one. The return value of the entire method is n because the expression n appended to last name has the effect of appending last name to n and returning the result of the operation. In addition to serving automatically as the receiver for bare messages, self also enjoys the privileges of being the owner of instance variables. The same topic. Kutoka wapi? Self. Okay.
Okay, thank you guys. See you on Thursday. We're heading over to the